Morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, I would like to discuss about what are the stresses induced in a shaft. So, in previous sessions, already we have studied the basics of shaft and types of shafts and how to design of a shaft by using strength equations and what are the strength criteria. So in this session, so what are the stresses induced in a shaft when it is subjected to different loads? So already you know the torsion loads and bending loads and the combination of these two loads and axial loads also will act on a shaft. While designing a shaft, all these values you should calculate. So then only you will get a good design. For any design, first you should identify what are the forces acting on that element. It may be gear, or it may be shaft, or it may be belt pulleys, and it may be couplings. First identify the forces and then calculate what are the stresses induced due to these forces. Suppose a direct axial load is acting on the shaft, then which type of stress will be induced? Tensile stress or axial stress. So you can calculate by using empirical relations. So already derived relations are there. The sigma is equal to force upon cross-sectional area. Similarly, compressive force, compressive stress, compressive load by cross-sectional area. So similarly, when it is subjected to direct shear stress, shear load. So due to this direct shear load, shear stress will be induced. And also, due to the torsional loads, the shear stress also will be induced. Similarly, bending loads. And combination of these two. So sometimes due to the self-weight of the machine elements, some bending movement also will be occur in the shaft. So that's why the design of the shaft, you should calculate all these forces and stress. So that's why you should learn that before designing of a shaft, what are the stresses induced, what are the standard stresses for a particular material. It depends upon the material also. And you should use some theories of failures. You know, the theories of failures are 5 theories. Already we have studied while designing a shaft on the strength basis when it is subjected to bending loads and torsion loads. One is the maximum shear stress theory, another one is the maximum principal stress theory or normal stress theory. You can say Rankine's theory. The maximum shear stress also called as Guest theory. So before applying those theories, you should know what are the basic stresses acting. The basic stresses will be induced in the shaft due to the various loads. See, in this slide, the following stresses are induced in the shaft. Already we have discussed the shear stress due to the transmission of torque, due to the torsional load. Shear stress may be occur, may be induced. That is, you can represent with top. And the second one is bending stresses. It may be tensile or compressive. Due to the forces acting upon machine elements. So already I told you, the machine elements are like gears, pulleys, etc. These are standard machine elements. As well as due to the weight of the shaft, due to the weight of the shaft, due to the weight of the machine elements, the bending stresses will be induced. So that's why when the shaft is subjected to twisting movement or torsion load, in that case need to calculate shear stresses. Why? So why? Because due to the transmission of torque, due to the torsional loads, shear stress will be induced. Not direct shear stresses, torsional shear stresses. Similarly, bending stresses. What are the forces acting upon the elements? So that is machine elements. Sometimes 2-3 gears and the pulleys also will be mounted on a shaft for transmission. In that case, need to calculate the bending loads and bending stresses. And also, as well as due to the weight of the shaft, the bending moment also will occur. And stresses due to combination of these two, torsional and bending moment. Suppose in the second case, the bending stresses will be induced due to the bending load only. There is no other loads like normal axial loads and shear loads and that is torsion loads. Only bending load. In this case, stresses will be induced in the shaft. In first case and second case, only it is for twisting movement, and second case is for bending movement, and third one is combination of these two. Next, the maximum permissible working stress for transmission shaft. So what are the working stresses for transmission shaft? Already I told you in the first session that shafts are divided into two types. One is transmission shafts and machine shaft. The shaft, in case of transmission line shafts are transmission shafts. All industrial shafts are transmission shafts. It transmit torque and as well as bending moment. But in case of machine shaft, not like that. The shaft integrated itself with the machine. So according to the American Society of Mechanical Engineers, that is ASME, code for the designing of transmission shaft, the maximum permissible working stresses in tension or compression may be taken as according to ASME code. One is 112, that is 112 megapascal for shafts without allowance for keyways. Second one is 84 megapascal for shafts with allowable allowance for keyways. So while designing a shaft, according to the ASME code, you should take these stresses. These are the standard permissible working stresses. You should take 112 megapascal for shaft when it is considering allowance without allowance of a keyways. If considering allowance of a keyways, 84. So for shafts purchased under definite physical specifications, the permissible tensile stress may be taken as 60% of the elastic limiting tension. So if you purchase the shaft under definite physical specifications, so you may take 60% of the elastic limiting tension, but not more than 36% of the ultimate tensile strength. So, in other words, the permissible tensile stress is equal to 0.6 times of elastic limit or 0.36 ultimate stress, whichever is less. You should follow these standards while designing a shaft according to ASME code. So that is according to American Society of Mechanical Engineers. You should follow. Sometimes in our problem, they may ask design a shaft um, according to ASME code. In that case, you should follow this condition. Next, the maximum permissible shear stress. Up to now, we have taken the permissible tensile stress, and in this case, the permissible shear stress. 56 megapascal for shafts without allowance for keyways, 42 megapascal for shafts with allowance for keyways. So here the value is 42 and 56. In previous case, tensile 112 and 84. For shafts purchased under different physical specifications, so what is the condition? The permissible shear stress may be taken as 30% of the elastic limit in tension, but not more than 18% of the ultimate tensile strength. So you may write sigma is tau is equal to 0.3 sigma EL or 0.18 sigma U, whichever is less. According to maximum permissible shear stress. Sigma tau is equal to 0.3 sigma EL or 0.18 sigma U, whichever is less. According to maximum working stress, the permissible tensile stress, 0.6 sigma U T is equal to 0.6 sigma EL or 0.36 sigma U, whichever is less value you should take. Here also same. Next, see in this slide shown what are the forces acting on a shaft. First one, shear force. So this is a direct shear force acting on a shaft. So that's why here shear stress will be induced. Second case, tensile forces. So due to this tensile force, tensile stress will be induced in the shaft. Compressive stress. The nature of load is here compressive. And bending moment. The bending moment is here shown in the clockwise bending moment. And torsions, the twisting moment. So due to this torsion, torsional shear stress will be induced, and due to this bending loads, bending moment, the bending stresses will be induced. So the bending moment will be induced due to the various machine elements mounted on this shaft. Due to the various machine elements, what are they? Like gears and pulleys. And sometimes due to the self-weight of this shaft, some bending moment also will be occur. Due to this bending moment, bending stress will be induced. So these are the common stresses will be induced in a shaft. Sometimes the combination of these two, the bending moment and twisting moment also will act on a shaft. Sometimes the shaft is subjected to fluctuating loads. Clear? So next, the stress at a point on the shaft is normal stress in x direction and the shear stress in xy plane as shown in this figure. In x direction, normal stress. In shear stress shown xy plane in XY plane, the shear stress shown. So from Mohr circle, according to the Mohr circle, you can write S1 is equal to the principal stress is equal to sigma by 2 plus square root of sigma by 2 whole square plus tau square. So similarly, the minimum stress, the maximum principal stress and the minimum principal stress, sigma by 2 minus square root of sigma by 2 whole square plus tau square. In this diagram, the shown in this Mohr circle, so the radius is here shown up to here sigma by 2 and the radius sigma by 2 whole square plus tau square. So this is this value here taken. So S1 value, the maximum principal stress value, and sigma 2, the minimum principal stress value. The maximum shear stress value shown here. According to maximum distortion energy theory, you can write these two equations, stresses equation, S1 square plus S2 square minus Sn1 into S2 less than or equal to Syp by N into Fs whole square. So that is, this is a factor of safety. So putting values of this S1 and S2 for after simplification, you will get the final equation. So like this, you have to calculate the stresses in a shaft. Here shown the most frequently the stress situation for a rotating shaft. Here shown diagram. The completely reversed bending and steady torsional loads, torsional stresses. So sometimes a shaft may have a reverse torsional stress. Both the rotating shaft, the most generalized situation, the rotating shaft may have both steady and cyclic components, bending stress and torsional stress. So you may write those equations according to Soderbergh's fatigue criteria. So already we have discussed in fluctuating loads of the fatigue topic. So according to the Soderbergh equation, you can write the equation for rotating shaft is like this. So sometimes you should the shaft design based on this type of fit also. One is clearance fit and transition fit and interference fit. So already we know. So what are the fits and tolerances? Here shown that a harbor press is used to mount the components onto the shaft. The mating parts have a clearance between them. This type of fit is called as clearance fit, also known as slip, slide or loose fit. Second one is transition fit. No clearance is present in between the shaft and the hole. It is also known as line to line fit. In this case, pressing is required. You have to apply hand force. Third one, interference fit. The shaft diameter is larger than the diameter of the wall of the component. Interfere. So this type of fit is called as interference fit. Some types of these fits are press fit and shrink fits. In case of thick and thin cylinders, we can see. Thank you. These are the references I have taken.
Like, share and subscribe. Hit the bell icon for more updates.